we go. Okay. So we're talking about matrices. Is this where we got? Did we finish that problem? I feel like in one of the classes we didn't quite finish. Yeah, we did get through all that. Okay, cool. All right, so again, the idea basically is that I want to take a system of equations, but as long as I know that this only really applies to linear stuff, but as long as I have kind of things like organized, right? So have like terms kind of matched up vertically here. Then all I really need to know is how many of each thing there are, right? So we form this coefficient matrix by just kind of peeling the coefficients off. Again, like technically it's an augmented matrix. That's what this vertical line is. But don't sweat that much. That just acts like the equal sign, basically. Then if I can take that and do row operations to turn it into something like this, which is row echelon because the ones down the diagonal and 0 underneath. This is actually reduced row echelon because of the 0 above. Then I can just read off the solutions, right? X equals 3, y equals -1. Let's do one more by hand just for the sake of doing it, and then we'll talk about I'll show you like how to do it with a calculator or computer or something. So here's a system of equations. This one is 3 by 3. If we're going to set up a matrix to represent this system of equations, again, like things that I would want to check first just to make sure is that I've got things lined up so that they're all the same kind of thing in each column. You're probably not going to see anything where they're not, at least relative to this class, but you do need that. That's part of the process. This would be 1, 2, 3 rows and 1, 2, 3, 4 columns. So this is going to be a 3 by 4 matrix. And then again, basically, I'm just going to take each equation, peel the coefficients off of each term, and then use those as the entries in that row. So this first row is going to have 4 entries. 1, 2, 3, 4. And they would be 1, 0, 1, 8. So what does the rest of it look like? One, 1, 2, 17. And then the last row, 1, 2, 1, 16. Okay with that part? Yeah? Easy, no big deal? Okay, cool. All right. I don't know if this is gonna fit in that half a page that's there, so just be advised. What I'm gonna work on first is the first column. Right, so what I'm going for here, what we want, and our goal is something that looks like that, right? We're looking for that row echelon thing, so that lower left triangle, I want it to be 1 down the diagonal and 0 underneath. The way I'm going to do this, because this is a place where, kind of like when we talked about 3 by 3 systems, just doing substitution and elimination, you can kind of end up like chasing your tail around a little bit if you're not like a little careful. I'm going to work on the first column and eliminating these 2 things. And then once I've got that, I'm going to move to the next column and work on eliminating that. And then I'm going to, try to like scale everything down to 1. Once I've got that first column in place, like I'm pretty much going to leave the top row and the middle row alone. And actually here, having a 1 right there already, like I'm probably not going to do anything to row 1 at any point in any of this, right? Because I've already got row 1 kind of where I want it. All right, so this and this. So what can we do? Yeah, I'm just going to go ahead and copy row 1 over because I'm not going to change it. What can we do to get rid of these 2 things? thinking again like elimination type operations, right? You can take rows and swap them if you want. You can add them together. You can subtract one from another. You can multiply, all the way across by a number if you want. What can I do to get rid of this? Subtract what? I mean, one of the other rows, right? So I can take row 2, there's 1 in this entry, there's a 1 in this entry. I can do like row 2 minus row 1. That would work, right? Because 1 minus 1 is 0, so that eliminates this. So, it's elimination, but we're sort of restricting ourselves to like thinking about what's right there and how that works. So I'm going to do row 2 minus row 1. All right, so that's 1 minus 1 and 1 minus 0 and 2 minus 1 and 17 minus 8. Right, so row 2 minus row 1. So 1 minus 1, 1 minus 0, 2 minus 1, 17 minus 8. Can we do something with row 3 at the same time? Can I do the same thing? Row 3 minus row 1. So go through each entry in row 3, subtract the corresponding thing in row 1. And then that's your new row 3. Like we're going to replace row 3 with that. So what's the first entry? 0. This minus that. Then what? 2. Then 0. And then 8. Okay, cool. So first column is where I want it to be then, right? Like that's what we're looking for. So now I'm going to move over. What else do we need to work on? If what we're shooting for is, 1's here, 0's underneath. I've got 1, 0, 0 there. I've got, this one where I want it to be. So I'm probably not going to do anything else with row 2 at this point. Like I'm going to leave row 2 alone also. So whatever we do next, I'm only really going to change what's going on in that bottom row. Now we're trying to eliminate this. I want a 0 where that 2 is in the third row. That makes it very hard to see. Eliminate that. So what can we use to get rid of the 2 there? I need to end up doing, 2 minus 2, basically. What do we got?
Multiply row 2 by 2.
Multiply this by 2, and then subtract. Yeah, are you cool with that? I'm trying to get rid of this 2, so I'm going to need to subtract 2. Well, the only place I have anything to work with is here in row 2. So multiply that by 2 and then subtract. All right, so I'm going to do row 3 minus 2 times row 2. This might be a place where there's like enough going on that you might, take it off to the side. 0, 2, 0, 8. That's row 3. Row 2 times 2. 0, 2, 2, 18. And we're going to subtract. So 0 and 0 and -2 and -10. So this is row 3. This is row 2, but I doubled everything. And then we're subtracting. And then the very last thing we need to do, like, okay, so now column 1 looks like I want it to, column 2 looks like I want it to. Only thing we need is I want that -2 to be a 1, right? To get that, again, like row echelon thing, right? So again, I know like some of this feels a little artificial, right? If I'm just thinking about solving a system, I can get it from here, right? Because -2z equals -10. But again, to like force it into that row echelon thing, I need that -2 to be a 1. Which, because I don't want to change anything else, right? I want to leave everything else kind of where it is. I can do by multiplying row 3 or dividing row 3 by -2, which will give you 0, 0, 1, 5. Now the whole thing has this, lower triangular row echelon kind of shape to it, which is what we're looking for. And I can start, sort of reverse engineering solutions from that. What's that last row say? One, but 1 is a coefficient on the thing that was in the third spot, right? Which, if you go back to the way we set the thing up, was the z term. So this says 0x plus 0y plus 1z, so z equals 5. If z equals 5, then that second row says that y plus z, so y plus 5 equals 9. And the first row says that x plus z, so x plus 5 equals 8. So the solution, x is 3, y is 4, z is 5. Okay, so we did some row operation stuff to reduce this thing, which again is just kind of like a sort of very specific version of elimination, right? It's elimination, but wanting to eliminate like particular things, right? So like we did that. Is everybody okay with how we get from here to this to solving? And once you have that row echelon thing, the bottom, the reason we're doing it in the first place is that the bottom row that gives you like a solution, right? It gives you one of the things. Then you can use that to kind of work your way back up, right? The row above it says, since its first entry is 0, these two things, y and z, add up to 9. Okay, well, I know that z is 5 now, so that means the y must be 4. And the row above that would have possibly x, y, and z. This one, the y term was 0, but it might have all 3, but you've got y and z at that point, so you can find x, right? So we just kind of, work our way back up to find the other entry, the other values. Okay. Okay-ish anyway. All right. Let's look at how you do this without having to do the whole thing by hand. I'm going to do this a couple different ways. So I'm going to do it in a calculator. This is, I know it like looks weird, but all the buttons and stuff are in the same place as TI like 84 or whatever. So if you have a TI calculator, follow along and push the same buttons. If you have something else, we can try to figure it out. I'm also going to just Google a thing in a minute and do it that way too. So it's all good. All right, so here on the left-hand side, there's an x to the -1 button. It's right above the x squared button and right under the math button. It's second or shift function, should say matrix. I'm gonna hit that. So second matrix. And what that brings up is a thing that looks kind of like this. It should have 3 options. names, math, and edit. You want to go to edit first because you need to like give it a matrix, right? So click on or scroll over to the edit thing and hit enter. And then there's a list, right? A, B, C, D, E, F. These are just matrices that you can store. So pick one. You're only ever going to need one at a time for this class anyway. Oh, I've already put it in there. So hang on. Delete. Oh, crap. Okay. Now I'll goof the whole thing up. All right. When you do that though, it's going to ask you for dimensions, right? Let me. Yeah. So edit, just select, A or whatever. It asks you for dimensions. It'll say like, 1 by 1 or 2 by 3 or something there across the top. Just tell what size matrix you want. So put in 3 by 4. We're gonna do the one we just did. So put in 3 by 4 there. And then it'll give you a big field with places for the 12 entries, right? Just go through and put them in. So 1, 0, 1, 8. Oh. Hit enter between them, which I didn't do just now. 1, 1. And obviously I didn't pay for this app, so I get ads occasionally, which is fun. Okay, so enter all the stuff. Once you've got the matrix entered in, you want to like back out. So it'll save it automatically once you have everything kind of entered in there. So then back out, just do second and then quit right next to it. So you've got the matrix sort of set up and stored in there, right? Now we want to like tell it to do the thing. So go back to that matrix menu, second to matrix again. You want the math option now because you're going to tell it to do a thing. So go to the math option and then scroll down until you find RREF, that's reduced row echelon form. Right, so that's going to be the sort of take the thing all the way down and just tell me how to solve it. And then you're going to have to tell it what you want it to do that on, right? So matrix one more time. And then under the first option where it says names there at the top, it'll just have all the things you have stored, right? So it'll say something like this, A equals 3 by 4. That's the one we just put in, right? That's the one I want to work on. So I'm just going to select that. So I'm telling it to find the reduced row echelon form of the matrix called A, which is the one that I just stored in there, right? So do that, I hit enter, and it tells me I have to buy the app if I want to do that. But yours and your calculator won't because you already bought the thing, right? Okay, so when you do that, it should spit out a thing that looks like what we got as solutions just now, right? It's going to be reduced row echelon, so 1 0 0 0 1 0 0 0 1 for the square part, and then you should be able to, in the last column, to just read the answers off, right? So, yeah. So back out, so quit. Hit that one more time. There. And one more time. Yep.
Go ahead, find it.
Just scroll. Wait. So in the matrix. Yeah, and then just scroll down. Okay, or if you don't have a calculator with you, or didn't buy the app like me, grab your phone or something and Google matrix RREF calculator or something like that. And they're going to be about 1 billion things that come up, and they're all going to work just fine, right? With various degrees of jankiness involved in the website, I'm sure. and ads and stuff. So, whatever, but choose a thing. And it's probably going to give you something that looks, I don't know, kind of like this. It's going to have you define what size matrix you want. If you need some oatmeal, then I can just go and grab that there while you're here. There we go. So define the matrix, right? I want a 3x4, so I'm going to click these boxes and change them to 3 and 4. And it'll give you little boxes to fill in, and we'll fill those in. 1 and 0 and 1 and 8. I know there's nothing more exciting than watching someone else type numbers. There we go. And since like the computer is going to do all the work for me, I'm just going to take a second to double check that I entered all those things right, because obviously that would goof things up. And then there should be some kind of enter or calculate. There we go, calculate. Depending on what website you're using, some of them will show you like step by step what's happening. Some of them will just spit out the answer. But there you go. Here's the reduced row echelon form of this thing. 1, 0, 0, and then 3. So x equals 3, y equals 4, z equals 5 would be the solution of the thing, right? So for something like that very last problem on the notes, where there's a 4x4 with 4 equations and 4 unknowns, what size matrix do you need to do that? 4x5, yeah. 4 rows, 5 columns, because there are 5 kinds of things. Set the matrix up by just peeling off all the coefficients. And then I would not do that by hand. I don't want you to do that by hand. Don't do that by hand. Don't come in tomorrow and say, like, I went to do the homework and there was this 4x4 system in there and I had to do it by hand. It took me an hour. It'd be all like ticked off at me, like, I am not telling you to do that. So, I mean, that's on you. If you want to do that, that's fine. Throw it into a thing, right? Your calculator, an online calculator, whatever. I'm not going to make you do this on the final. So, like, put that out of mind. I don't want, people who have a fancier calculator to have an advantage or whatever, or not be able to do it. So, like, it's not on the final. You're not going to have to actually do this there. But you do need to kind of understand how it works and know how to interpret things and that kind of thing, right? So, do the thing and let a calculator do the thing for you. And then interpret that what this means is that x equals 3, y equals 4, and z equals 5 is the solution. So do that 4x4 real quick, number 8 on the notes. However you want. Do it with your calculator if you want. Do it with whatever online thing you're using. -3, -16, -3, 3, -1, 4, 20. This. What does that mean the solution to the system is? There are 4 things we didn't know. What were they? W, X, Y, and Z. We put them in that order, right? So reading down this list, what's the solution? Got reduced row echelon, right? So ones down the diagonal, zeros everywhere else, which means that this would be W, right? The first position is -1, X is 1, Y is -2, Z is 3, right? So that ordered quadruple, I don't know, whatever the word is for 4 things, would be that. Would be that -1, 1, -2, 3, W, X, Y, Z. Okay, good. Okay. One other quick thing. You can get stuff here where you get kind of a weird result like that. Or that. Weird cases. Let me just say that. What does this say? And again, I would probably start by paying attention to like the bottom row. What does the bottom row say? Yeah, everything's gone, right? So 0x, 0y, 0z, so 0 equals 0. What does the bottom row say in the other one? 0 equals 1. What does that mean? It's not what we like expect to see, right? Because what we expect to see in like row echelon is 0, 0, 1 in that bottom row, for 1z, and then the answer is sort of across from it. Here's z dropped out of both cases. One of them we get 0 equals 0, which is true, but doesn't seem all that helpful. The other we get 0 equals 1, which is not true. What does that mean? We've seen this before. We've seen this exact same thing happen with 2x2 stuff. What did it mean there? If that's not true, if we get a thing that's, like logically false there, what does that mean about what's happening in the system? Flip back to notes from last week if you want to. Saw the same thing happen there. Graphically, we're thinking about intersections of things. They're like parallel. Yeah, it means there's no solution. There's nowhere that they all cross, right? In the 2x2 case, we're talking about lines in the plane, so they're meant that they're parallel. Here we're talking about planes in 3-dimensional space. Like it's a little bit more complicated than just parallel, but what it means is that they don't all intersect somewhere, right? There are kind of more options because you can move in more directions, but it means that there's no solution. If you were trying to do that, with equations, like doing elimination type stuff, you would find at some point a similar kind of thing coming up, right? 0 equals 1 or 0 equals 5, or it doesn't have to be 0 and 1, but something that's just not true, right? That sort of like one of the things just kind of disappears and you get a statement that doesn't make sense. What does this mean then? Well, what it meant in the 2x2 case is that you had lines that were parallel, that had the same slope, but they also had the same intercept. So they were kind of coincident, like they're sitting on top of each other. And you got infinitely many solutions. It means basically the same thing here. It doesn't have to mean that they're all three the same plane, but what it means is that they intersect in a whole line. So instead of just a single point, you get a whole line of solutions. And the way you would sort of express that again is to, think about this. This says that y plus z equals 3. This says that x plus z equals 2. Well, that means that x is 2 minus z and that means that y is 3 minus z. So I could write those solutions like 2 minus z, 3 minus z, and z, right? Similar to, again, what we did with the 2x2 system. You get a whole bunch of solutions. That doesn't mean that everything works, right? There are these 3 planes in this room. They intersect in a whole line somehow, right? But that doesn't necessarily mean that this point right here is on that line, right? So what we do is basically parameterize it in terms of one of the things. Here, both of these have z in them, and that's kind of how the thing, tend to work. So I find those, write them in terms of z, and then I can write like an ordered triple that if you give me a z value, I can find the x and y that go with it, so we land on that line. Right. So again, same idea as what we did before, only there's 3 things now instead of just 2. Okay, but that's what these sort of like weird cases would look like. And the thing that always tips you off is that bottom row. If you get it, all the way sort of reduced down the row echelon, the bottom row is going to look weird and in a way that like either kind of makes perfect sense but doesn't seem all that helpful, or a way that doesn't make sense. Well, means that there's no solution. There's nothing that actually works. Okay. Okay. Now,